If the player runs into a wall while holding the corresponding inputs, they will wall slide. The falling speed will gradually increase while sliding. This system works with the previous wall run mechanic. The player can press space to wall jump and can double jump too. If while sliding the player looks to an angle, they will switch to wall running. There is one customizable, which is the wall run delay time. This controls how long the player must wait after wall sliding starts to wall jump. When the value is 0, there is no delay, so the player can immediately jump from wall to wall. For this video, I will be using functions made in the previous wall running video, so if you want to follow along for this one but you haven't for wall running, then you will have to do that one first. First we will get one animation from Mixamo which will be hanging idle. Make sure to download it without skin. I will use the Mixamo converter to convert it to a UE5 rig. I will link this software in the description. Next, open Unreal Engine. I will make a new folder for wall jumping. Make a new folder for animations and import the hanging idle. Rename it to wall slide left, then duplicate it and rename it wall slide right. There were no animations for wall sliding on Mixamo, so I am going to edit this one using curves. To make an edit to an animation, transform a bone and press the Add key button at the top. For this, make sure you are at the start of the animation so the modification is applied throughout by default. I will speed up this part and show you a good final pose which you can use as reference. Now open your character blueprint. This video is an extension of the wall running video, so it will use variables, events, and functions from it. Make a new custom event called Start Wall Slide. Make a new Boolean variable called wall sliding and set it to true. Next, set trace forward to false, which is a variable we made in the wall running tutorial. Next, set the gravity scale to 0.1. This makes the player appear as if they are sliding as they aren't falling as fast. Then make a new variable called canWallSlide. Make its default value true and set it to false in the event. Make another variable called canWallJump, setting it to false as well. Then get the character movement and stop movement immediately to make the player stop any movement prior to starting sliding. Then call the reset wall run event. This is to ensure that running and sliding do not interfere with each other. Add a sequence, with a retriggerable delay and then 0. Set the duration to 0.5. Then set can wall slide to false and trace forward to true. In then 1, add another retriggerable delay and promote the duration to a variable. Name it wall jump delay time. This is a customizable which decides how long the player must wait after sliding starts that they can jump. It can be set to 0 if you want no delay. Set can wall jump to true on completed. I will now comment the event. For the next event, duplicate start wall slide. Rename it reset wall slide. Delete these 4 nodes as shown. Copy the hand IK nodes from the reset wall run event and paste it in the new one. Set wall sliding to false and the gravity scale to 1 in this event. Rearrange the nodes as shown. Now make a new function called wall slide foot trace. This will trace if the player can slide by checking if there is a surface to place their foot on. Add a line trace by channel. For the start position, get socket location of the mesh and subtract vector. Set the z value of the subtract to 15. This makes it so that the trace is done a bit below the foot so it will predict earlier whether they should stop sliding. For the socket, add a select node with wall run direction as the index. If left, then set it to foot_L, if not, then foot_R. If you are not using the Unreal skeleton then the socket names may be different. For the end position, add a vector. Get the actor forward vector and multiply it by a float for the addition. Make the value to multiply by an input called trace forward. Set the default value to 50. I will promote the draw debug type to a variable so I can debug it easier later when testing. Add a return node and drag the return value and outhit into it to make them outputs. Make another function called wall slide hand trace. This will be similar to the foot trace but checks if there is a surface for the hand. Add a line trace by channel. Get the actor location and add vector. Split the struct pin. Set the z value to an input called z offset with a default value of 110. Next add a pin to the add vector and get the actor right vector. Multiply this for the addition. Set it to a float with a value of 25. Add another pin of type float and add a select node for it. The index is wall run direction. If left then set it to -1, if right then 1. Set this as the start position. For the end, add a vector. Get the actor forward vector and multiply it. The value will be a float input called right offset with a default value of 50. Add a return node with the same outputs as the previous function. Now we will add on to code from the previous video for the on component hit. Make some space here. Get wall sliding not and set it as another input for this end condition. This is since we should not wall run if wall sliding. If this branch is false, add another branch. Add the get input direction function. Get the forward vector of the fixed output. Get the dot product of this and the wall run normal. This code is explained in the previous video. Check if this is less than 0.4 for the branches condition. If true, call both trace functions. Change the default value of the foot trace's input to 80. Add a branch node. Add an AND operator with 3 inputs. The first 2 are the return values of the trace. The final one is can wall slide. If true, add a sphere trace by channel. This is for an initial ground check to ensure the player isn't too close to a ground when wall sliding starts. The start location is the mesh's world location. The end location is the same with a subtraction in z of value 110. This value will be fine-tuned later. Set the radius to 10. Drag out of the return value and add a branch. If false, then start wall slide. Also set the gravity scale to 0.1 here, as I found a bug where it would only reduce gravity after sliding once when setting it only in the start wall slide event. This value to subtract by should be such that when jumping into a wall while grounded, it should either wall slide right at the maximum value or just after the maximum value, although this is up to the developer's choice. For example, a value of 130 enabled me to start wall sliding right at the peak height the player reaches when jumping. Therefore increasing it to 140 makes it so that I cannot wall slide if jumped while grounded. Next go to the start wall run event. Add a new pin to the sequence and call reset wall slide. This is so when wall running, wall sliding is 100% disabled. Next go to the movement input and make some space. Add a branch that only adds the movement input if not wall sliding. This is since while wall sliding the only input we should be able to give is to jump. Now make a new function called wall slide tick. Add a sphere trace by channel. Get the mesh's world location for the start and end. Set the radius to 10. This is a ground check that occurs while sliding to check when the player has reached the ground and should stop sliding. This is being used instead of on landed because the system makes it so the player stops sliding before they actually hit the ground. Add a branch using the return value. If true, then call reset wall slide. If false, then add the wall slide foot trace function. Add a select float for the trace forward amount with the condition being trace forward. A is 10 and B is 80. This is done so that the player can detect a wall in front of them for wall sliding even in the falling pose where the feet is further away from the wall. Add a branch with an and condition with the first condition being the return value. The second one is the same code we did with the input direction, but this time use the relative direction and check if it is greater than 0.5. This makes it so that we have to be looking relatively directly to the wall, otherwise sliding will stop. You can change the greater than value to modify this threshold. For the final condition, get IA_move. Split the pin and check if either of them is not equal to 0 using an OR operator. This makes it so that if there is no movement input given, wall sliding will stop. Break the hit result of the trace. Set the normal of it to wall surface normal if true. If false, call reset wall slide. Add the wall slide hand trace function in the true path. Add a branch using the return value, then add a sequence. If the branch is false, call reset wall slide again. This is if the hand IK trace does not detect a surface. Get the wall run direction and add a switch on node. Break the hit result of the hand IK trace. For switch on left, set the wall run hand IK left location. Then set the left alpha to 1 and right alpha to 0. Do the opposite for switch on right. Add a vector to the impact point. Multiply the normal by a float of 4 for the addition. This sets the hand IK position to a distance away from the actual detection, so the hand is not inside the wall but placed on the surface. Set this to both hand IK locations. Next we will apply gravity. Get the gravity scale from the character movement and add a value of 0.001 to it. Clamp this between 0 and 1. You can change the max value if you want the gravity while sliding to be limited to a different value. Then get the character movement and set the gravity scale to this. This gradually adds gravity while sliding. You can increase or decrease the rate of change by changing the value in the add float. I will now comment the function. Now we will call the wall slide tick. In event tick, add a branch that calls the function if wall sliding. As explained in the previous videos, event tick is not the best way to do this as it checks every frame, so it is better to use a timer or loop timeline, but I was unable to make them work with a smooth IK system. Now open the character's animation blueprint. Promote wall sliding to a variable here. Next, open main states. Duplicate the wall running state and rename it to wall sliding. Make a transition from fall loop to it and back. If going to it, the condition is wall sliding, if coming back then wall sliding not. Make transitions between wall running and wall sliding with the condition being the corresponding variables. Now replace the two animations in the wall sliding state to wall slide left and wall slide right. Finally, we will add the IK. I will rearrange the nose from the previous video to make more space. Duplicate the two transform bone nose. Set the rotations of them to -90, 0, 0. The alpha is each hand IK alpha multiplied by wall sliding. It is working, but the animation is not playing on the legs. This is due to the foot IK. To fix this, add a pin to this multiply. Set the condition to wall sliding not. Now the system is working correctly. Go back to the character blueprint. Finally, we will add the wall jump and double jump. Go to the jump code from the previous video and make some space before the second branch. Replace it with a branch that checks if wall sliding. If true, then check if can wall jump as well. If this is true as well, copy the air control and launch character nodes from wall running jump. I will change the launch velocity Z to 700. Next, call reset wall slide and set can wall run double jump to true. If the branch is false, then connect it to the default branch we moved. After setting can wall run double jump to false here, call reset wall slide again to ensure it is 100% disabled. Finally, set the gravity scale in wall run on landed after the air control. Set it to its default value, which is 1.75 for me. I will now make a test map to showcase all the features. Player can go from wall running to wall sliding. The two are selected based on the angle and input the player runs into the wall using. The player cannot wall slide if there is no surface for the hand or foot to be placed on. The animation isn't perfect since it is just a modified one using curves, so you can replace it with a better one if you have. That is all for this video. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.